Traditional SQL databases excel at one thing: matching exact keywords and organizing strictly structured numbers into rigid alphabetical tables. But today's digital landscape looks completely different. The vast majority of the information we generate, from massive text files and audio recordings to images and AI prompts, is completely unstructured. To see where the old systems break down, imagine trying to search a library for a very specific vibe. Say you want books about wealthy, lonely men throwing lavish parties in the 1920s. If you feed that exact phrase into a standard database query, it returns exactly 0 results. That system can only find what it explicitly knows. Unless a human librarian took the time to manually tag a book's metadata with those exact words, the database remains completely blind to the underlying context. Because we are now swimming in unstructured data, exact keyword matching is hitting a wall. We need a system built to search for conceptual meaning rather than identical strings of text. This is where vector embeddings come in. They act as a translation layer, taking abstract human ideas and converting them into machine-readable mathematics. When an AI model processes information, it spits out a massive array of numbers. Often, a single concept translates into a sequence measuring from 768 to over 1,500 dimensions long. Each individual number in that sequence represents a highly specific feature, tone, or characteristic identified in the source material. You cannot easily cram these multidimensional lists into the rows and columns of a standard spreadsheet. Storing and searching through them efficiently requires an entirely different architectural framework. By breaking complex concepts down into these dense numerical arrays, we successfully map abstract human meaning into exact, measurable mathematical coordinates. That framework is a vector database. It operates as a multi-dimensional coordinate space, where vectors sitting mathematically close to each other represent semantically similar concepts. Imagine an endlessly massive 3D museum where every book ever written floats in midair based purely on its tone. In this space, books about tragic romance cluster tightly in one corner, stories set in the Roaring '20s float together nearby, and books discussing societal critique hover right between them in an overlapping zone. This 3D spatial scatterplot shows what happens when you run a similarity search. Your text query is converted into its own set of coordinates and dropped directly into the floating room. The database calculates the physical distance between your prompt and the surrounding points, using metrics like cosine similarity or Euclidean distance. It instantly identifies its nearest neighbors, pulling up titles like The Great Gatsby. It retrieves the perfect match without relying on a single shared keyword. In a vector database, mathematical proximity equals semantic meaning. This ability to locate context on the fly is how we give large language models a working memory. Through a process called Retrieval Augmented Generation, or RAG, a vector database fetches relevant private documents and feeds them to the AI, allowing it to reference your specific internal data. The technique extends entirely beyond text. Multimodal search lets you scan through massive databases of images, audio, and video using everyday conversational language. If you search for 1920s flapper style, the system ignores the text of the file name. It evaluates the visual aesthetics of the era, retrieving matching sequin dresses and feathered headpieces. You also do not necessarily need a sprawling, dedicated server cluster to do this. Modern analytical engines like DuckDB now support vector similarity search extensions, letting you run these contextual lookups right alongside your traditional SQL workflows. We are moving past the days of forcing users to guess the exact phrasing of a file name. We are transitioning from querying what things are called to querying what things actually mean. By translating abstract thought into spatial mathematics, the vector database serves as a bridge. It allows computational systems to finally parse, understand, and navigate the messy, unstructured reality of the human world.